Okay, this video will complete your notes on section 6.2. These are volume of cross-section examples. You should have a printout with all the problems already, and this areas to know as well, so you can have that for reference. So you should not have to write these examples. If you do not have a calculator already, please go ahead and get one because we will be using one to solve all of the problems in these examples. So we're going to do examples 2 through 4, and that will conclude our notes for this section. So the first example says, find the volume of the solid when the base is the region bounded by this equation and this equation, whose cross-section are perpendicular to the x-axis, which means this is dx, and our shape is squares. Okay, so there are two things when we're finding volume with cross-sections. The first thing we need to figure out is the base. So that will give us the whole shape from top to bottom. So, since this is dx, that means we need to do top minus bottom. Okay, so let's see. We need to figure that out. We're going to use our calculators for this. So go ahead and turn on your calculator. We're going to go to the graphing screen. So that means pressing green diamond and F1 because that'll take you to your y equals. Go ahead and clear out whatever is there because we need to type it in. Even if it's the same things, you need to practice typing. So we're going to type this first equation. So we're going to type in 4. And then we need the logarithm. There's not a logarithm button shown, but there is a logarithm button in general. If you do the green diamond and then the number 7, you will get a log base 10. So green diamond 7 will give us our log. And then we have 3x plus 2, and we close our parentheses and hit enter, so that will bring it up there. And then that's our first equation. Our second equation is 2x squared minus 8x minus 1. Hit enter so that it's in there. And then we need to graph this. So that's green diamond F3 will bring us to our graph. You can see that this says busy. If it says busy, that means it's working. Sometimes some of these take longer to graph than others. It just depends on how complicated the function is. So there is our log function. And there is our, oh, did I type something wrong? 4 times the log of 2, 3x plus 2. Yep, 2x plus 3. That was all kinds of wrong. Okay, let's go back. So, after you type in the correct question and it graphs it, we can see that the logarithm function, there's our logarithm function. We know x squared, even if you don't know what that looks like, we know x squared is a parabola. So the next thing it graphs is a parabola. So our log function is the top, so we're going to have 4 log of 2x plus 3 minus the bottom, in parentheses, 2x squared minus 8x minus 1. This is our top minus bottom. So this is our whole base all the way across. So when we look at our area formula for a square, we look at our areas to know. For a square, area is side squared. So our area, an entire side of a square, we want this whole thing. So it's this squared. That's what will be in our integral. So when we set up our integral with this, we have the integral. We don't have our bounds yet. I'll show you how to get those in just a moment. Of this equation, 4 log of 2x plus 3 minus 2x squared minus 8x minus 1. All squared dx. So we need those limits. Those limits are going to come from where these two graphs intersect. We can actually literally find that. If you go to your math tools, which is F5, the 5th option down is intersection. This can tell us our exact intersection. So the first thing it wants to know, what's your first curve? It doesn't matter the order of these, you just need to pick a curve number 1. There you go. Second curve, make sure it's on the other line, hit enter. They want a lower bound. They're thinking about the x values. So we go to the left before so that we're on the other side and hit enter. And we go to the right so that we're on the other side and hit enter. It wants us to know, because it needs to know which one of those it's looking for. So our intersection is that gross decimal right there. So that's our A is negative 0.294437. We will write that entire decimal down. Remember, the calculator is doing work for us, so we need to give it as much information as possible. Now we need to find the other intersection, so we're going to repeat that process. F5, first curve. Yep, that's on my top one. That's on my bottom. Top and bottom doesn't matter. Okay, lower bound. I already am lower for my other intersection, but I'm going to get closer, just personal preference. Upper bound, we're on the other side to the right. Hit enter. There's our intersection. B is 4.58268. There is another way we can find these intersections as well. I'll show you that on the next example. But we need to put this whole integral into our calculator. So this is going to go here. So we go home and we can integrate. Look right above the number 7 again. There's our integral symbol. There's another way to get it, but that's a shortcut. So we are going to integrate. We're going to type in this whole thing, making sure we have all the parentheses and stuff we need. So integral, and it's starting, so that's our first bracket. So we have 4. Remember, log is green diamond 7, even though it's not written there. I'll type the right one in this time, 2x plus 3. And then we are going to subtract. You can either distribute that negative or put it in parentheses. So we have 2x squared minus 8x minus 1. Close those parentheses. And then close. Okay, we need all that to be squared. So we're actually going to need another 1 because before we integrate, we have to square it. So we're going to need to add another parentheses in there. Square that. Before we close the integral parentheses, we need a dx. In our calculator, that's comma x. We also don't have our limits yet, so we need to type that in. So we're going to do comma, our first limit, which is negative. Make sure you use the negative down here, not subtraction. Those are different. You'll get a syntax error. 0.294437, comma, our other crazy decimal, 4.58268. Then you close your entire parentheses. We have all of this information in here. Hit enter. Sometimes it takes a minute because this is a lot of calculation, a lot of things you'd have to do by hand. So sometimes it takes a minute for our calculator to give us our answer. But our answer is 401.874. And we'll just write everything on the screen. And that's our first area by cross sections. Let's look at our second one. So this is our third example. Our third example says find the volume of the solid. The base is the region bounded by this equation and this equation whose cross sections are perpendicular to the x-axis, and they are semicircles. Okay, so first thing, what's our base? Well, this is a dx question, so we need to do top minus bottom. So we need to figure out where those are. So we use our calculator. Clear out what we already have, and let's type those in. So we have e to the x plus 2. E to the x is the x button, green diamond, x button, in that order. E to the x, close the parentheses, plus 2, hit enter, and it should look like this looks. Make sure that those match. And then our second equation is negative x squared minus 2x plus 4. Hit enter. Make sure it matches, and then we can graph. If your graph is not centered, because it's zoomed weird, you can center it by pressing the zoom button. If you press after it's graphed and it doesn't say busy anymore, F2, zoom standard will bring it back to a 10 by 10, but mine's already there. So let's see, I know what a parabola looks like. So this, actually the parabola is on our top. So this is the top, so we're gonna have negative x squared minus 2x plus 4, and then minus e to the x plus 2. Now be careful with semicircles. This is the only one you really have to watch out for. Because remember, this gives us our whole shape. So if we are like, here's our, that's not a good picture. Here's our area. So it's kind of like this. And then something like that. maybe? Okay. Remember, out of here, what's happening is they're making a semicircle all the way across. Those are our cross sections. I had an example in class made of like the felt paper, like it looked like a purple tornado. So that's what's happening. So look at this. Top minus bottom is all the way across our circle. So when we look at our area formula for a semicircle, which is half of a circle, it is 1/2 pi r squared. Is all the way across a circle the radius? No, it's the diameter. So how do we change this diameter, this is the diameter, into a radius? Well, you divide it by 2. So we have to put a 1/2 in front of this to make it what we put in here. So 1/2 and pi are just numbers. So when I make my integral, I'm going to put them in front of my integral. I don't have my limits yet, so I'm just going to leave a and b blank for a minute. 1/2 pi in front. And then I need r squared. Well, all of this is my radius. So I have 1/2. This is why we're very glad that these are calculator questions. Negative x squared minus 2x plus 4. I'm going to distribute that negative. Minus e to the x minus 2. All of that, including the 1/2, is squared. This is a dx problem. The last thing that we need are our limits. So instead of, we can, F5, go to the intersection. There's another way to find these. Remember, to find those limits, the first time that, like when we did area and stuff, we just took these equations and set them equal and solved for x. Our calculator can also do that. That's an algebra skill. So you're going to go to solve. We want it to solve this equation. We're going to set these two equal to each other. We're going to say e to the x plus 2 equal to this negative, make sure you're using this negative, x squared minus 2x plus 4. Before you close those parentheses, though, make sure your calculator needs to know what it's solving for, because calculators are not smart. They only do what we tell them to do. So, comma x, solve for x, please. Close your parentheses and hit enter. Now, depending on the difficulty of the question, it might take a minute. So you can see that this says it's busy. That means it's working. It's trying to solve this for you. So we just have to let it do its thing. And eventually, our answers will pop up. There they are. So our first answer is smaller. Right here, our A is negative 2.71279. Woo. B is positive 0.289865. We're going to use all the digits that are given because we want our answer to be as specific as possible. So this is the integral that we need to put in our calculator. So let's clear out what's in the home page. I'm going to put 1/2 pi first, and I'm going to write it as pi over 2, just for simplicity's sake. So pi is over here, second. Over 2 means divided by 2. And then times our integral. Second 7 brings up our integral. And we need to type this. So all of this is squared, so we need an additional bracket or parentheses. And we do 1/2 times negative x squared minus 2x plus 4 minus e to the x, close those parentheses, minus 2. All of that needs to be squared. Before we close our integrating parentheses, we need a dx, which is comma x, and we need these two. So we can just copy them from right here too. We didn't really need to write them down necessarily because we can copy it from right there, but if we're asked to show our work, then we do. So comma, our lower bound is negative 2.71279. Whew. Our upper bound, 0.289865. Close our freaking parentheses and hit enter. And now I'm missing a parentheses. It's probably here. Yep. because I was multiplying. The reason why I knew that is because I was multiplying by 1/2. And then later on, I was squaring. So I needed to make sure that I multiplied by 1/2 for those parentheses, and then I had another set of parentheses to square. So that's how I knew where it went. So that's our answer, which is significantly smaller than our last one. So 4.47819. I go ahead and write all the decimals on my calculator, but remember for AP Calculus, you need to at least have 3 decimal places to get correct. Even if you put that 4.47, wrong. You do not get your answer point. So please write down all 3 decimal places. To be safe, just write down everything that's on your screen because it's really not that hard. Okay? So, 4th example and our last example. Let's go down here and erase that. And our last example. So let's see. Find the volume of the solid when the base is the region. Bounded by, those are relatively nice equations. Y equals x to the 5th plus 2 and y equals 4x plus 1 in the first quadrant, okay, whose cross sections are perpendicular to the y-axis and are right isosceles triangles with a hypotenuse in the base. So that looks like a very descriptive, ridiculous thing, but it is one of our area formulas. So here's our area formula. I'll go ahead and write that. So right isosceles triangle with the hypotenuse in the base. So we can go ahead and 1/4 side squared. Okay, cool. We need to figure out our base. However, this is a dy question. And we have y equals x to the 5th plus 2, and we have y equals 4x plus 1. Both of these need to be in the other terms. So I need to subtract 2 and take the 5th root, which is the same thing as doing a 1/5 power, which is easier to write in our calculator. So these will cancel, and I'll have x, and this is y minus 2 to the 1/5. This one, subtract 1, divide by 4. So I have y minus 1 all divided by 4. So these are my 2 equations. So because this is dy, I had to make them in terms of y. So that's what I'll use. But when we graph them, our graphs don't happen like our calculator. We can't change the fact that they're in terms of x. So we have to, what we type into our calculator has to be what we started with. It's the same graph, like nothing changes. So x to the 5th plus 2 is the same graph as this. Like that's how doing the opposite works. 4x plus 1 is what we're gonna graph over here, but when we input it, we're gonna use this. So when we get to our graph, let's see which one's on the top and bottom. Well, this one's gonna be a line because it's 4x plus 1, and that one should be a curve. So there's my x to the 5th, and there's my curve. Ooh, I can't see everything. So let's zoom out. Zoom out a little bit, maybe. Let's, our new center, it looks like we want the middle. I mean, let's guess, somewhere up here, maybe? Let's try to look for this whole thing. Where's our line? There she is. Did I input those right? Oh, no, did it again. There we go. There, now you probably don't have to zoom if you actually did the question that you're supposed to do. So I'm gonna zoom regular again. I'm gonna go back so that I can like actually see what's going on. So zoom 6 will bring you to like a 10 by 10. So let's see. dy, careful, means when we think about our base, we're doing right minus left. Okay, so when we do this, we are looking for these two. It says in the first quadrant. So the thing that's between them right there is right here. So the one on the right is the x to the 5th, which is this equation. And the one on the left is the line, which is this equation. That's because that's the shape bounded between those two curves in that quadrant. Okay, so there's our right minus left. So what do we need to do to that? All of this goes into our area formula. So we have, when we write our integral, I'm going to write the 1/4 out front since it's just a number. And we have y minus 2 to the 1/5 minus y minus 1 over 4. All of that is squared. And this is dy. Now be careful because we're going to need these y values. Okay, so two ways we can do this. We can either do the intersection here, but just be careful. Okay, let's see. First curve, check. Second curve, check. Lower bound here. Let's go in the middle here. So if you do this, the x value is not your intersection. The y value is, because this is all in terms of y. So that's our lower bound, so that comes here. So we have 2.00098. And then our upper bound, we can do the same thing, or we can put in a solve. So we can use algebra to solve. We want to solve these y equations. So this is y minus 2 to the, in parentheses, 1/5 is 1 divided by 5, equal to this one, equals, we want y minus 1 in parentheses, all divided by 4, comma y, because now it's solving for y. Waiting for the answers, because it takes a long time, because that equation is not easy to solve. It's faster than we could do it though. So when you get that, let's see. So remember, in the first quadrant, negative numbers are not in the first quadrant. That number is, which we already got. And then this number is, which we already got. So just be careful when it says the first quadrant. Make sure you're using all numbers that are in the first quadrant. Okay, so now we just need to integrate this. So we have 1/4 in the front. Integral, we need to square all this, so we'll have parentheses. And then another set of parentheses to raise the y minus 2, all to the, in parentheses, 1 divided by 5. Minus that. So minus, lots of parentheses. Y minus 1 needs to be in parentheses, divided by 4, and then close the parentheses, so all of that is subtracted. And then we're going to close them and do to the squared, and then do comma, dy is comma y, comma, lower limit, 0.00098, comma, upper limit, 6.37298. Close your integration parentheses, hit that enter button, and wait for that to integrate and give you a really small answer, 0.14028. Cha-ching. Okay, so those are all of our examples. You do have a, you do have a assignment on Canvas that you need to finish, which is due when you get to class the next day. Okay, so that's it. That concludes section 6.2.